Okay, in this video, we are going to take a look at structures in Rust. There's a few things that are a little different than structures in most other programming languages. Overall, they work pretty much the same way as they do in C and Go and C++ and those kind of things, with a few differences. So, the first thing I want to mention here is you'll notice that I have my brackets lined up differently than most people do. This is just something that we have always done internally. You can format this stuff any way you want. Most people, if they're doing this, they'll have it formatted in this way. One of the problems with doing that is I use VI as my editor, and I like using if I hit the square bracket twice, it goes down to the first line of each function. So it's a quick way to jump through your code to try to get to the next thing in line. If the thing is lined up like this, if it's lined up like this, it won't do that. It skips over it. So if you don't like the way that I have my code formatted, get over it, because I don't really care. Now, a structure. What is a structure? Well, a structure is the same thing as a variable. So think about a variable, which is in this case an I32. So this is an integer signed, which means it can be negative or positive, and we're referring to it as I in this example. Down here we have an S variable, we have a P variable. So a variable is a variable. Now, a structure allows me to define a variable. I can actually say that I want my own variable, and in this case, I'm calling it S1. Now, the compiler wants you to have an uppercase letter here to start this thing out. It doesn't like the structures to be lowercase, so you can use your camel case, but it needs to start with an S. But we use the struct keyword and whatever you want to call it, and then you have your open and closing braces. Now, inside of that structure is where we define what we want to be part of it. So if you think about a structure, it is the ability for me to group variables together to say that they have a relationship. So instead of just having an integer for this and a string for this and a file handle for something else, I can actually take everything that I use to work with this particular object, and I can group all of those variables together and say they're all related. And then I get to them via dot notation. So you can see down here when I actually, or right here, and I'll explain self and all this in a minute, but you'll notice I use a dot notation to get to that. So that's kind of the way that works. It's pretty straightforward. Now, you'll notice that in addition to me being able to define this structure, I can also use an implementation block, which you refer to as IMPL, and then I'm telling it that I'm implementing S1. So the structure S1 is made up of these variables, but then I'm going to define some functions that are going to go along with that variable, and I can only call this function from within an instance of S1. Now, why would I do that? Well, if you go back to like a C program where you define all these functions and you call the function and you do certain things, there's no relationship between the function and structures or certain things that I'm working with. I can literally pass anything, call anything, do anything I want to do. Well, in Go and Rust, I have the ability to tell the system that, look, I'm going to define a function here, but I want this function to only be available from this particular type of variable. So in this case, and you've seen in the other videos where we're going and doing things, you've seen this in action, and you'll kind of understand it more as we go through. But I'm telling it that I'm implementing I'm implementing functions that are going to be related to S1, so I can only call this set function from an instance of an S1. Now, what is the difference between the variable type and an instance? Well, the variable type says this is what I am. This is an I32, this is an S1, this is a string. That's just a variable type. But when I declare an actual variable to be that type, now I have an instance of that particular variable. And so when I define an implementation, I'm telling it that this function called set can only be called from an instance of S1. Now, here's the immediate problem is, well, okay, I'm going to write a function to work on the instance of this thing, but say I have two S1s. I've got one called P and one called Q. Well, how is it going to know which one of those instances it's supposed to operate on? And so the way that it knows that is with this self keyword. So self is what I'm going to use to refer to the instance that I called the function from. Now you'll notice here that I have self, and then I've also got a couple other variables that can get passed in as well. So when we call this, we're calling right here, you can see, and this is something else to understand. If I want to change either of these variables, once I declare an instance of S1, I don't declare the structure as being mutable. That the structure is the structure. That's the variable type. So nothing in here is mutable or immutable. But when I declare an instance of that structure, I can put the mutable keyword in front to say that I want to be able to change P. I want an instance of S1, but I want to be able to change it. I don't want to have it be static. And so I put the mutable prefix here to tell it that I want to be able to change P. Now, when I declare this instance, I'm just saying let P equal S1, and then I have open and close parentheses or open and close braces that I put the fields in. Now this is also something that you have to learn because it's a little bit weird. So when we declare this structure, we are going to put open and close parentheses in it. Now, normally you might put parentheses and then put the fields in it, but in this, we're putting actual braces. And then you'll also notice that we're not saying I equals 22. We're actually doing an I colon 22 and a comma after each field. Again, notice that we have a comma on the end. Now, this is a little different in most programming languages. When you do something like this, you would normally not have a comma here because that's the last field in that sequence. But in Rust, you actually do. And I actually like it. It's just something I've got to get used to. And the reason I like it is if I wanted to add a Q here, then I just go in and add Q. I don't have to go to the previous line and add a comma and then come in and add another line without a comma. So it is nice that it has that comma on the end, but that's something to get used to. Now, another thing that you'll notice is that when we declare this variable, we have to put a semicolon on the end of our brace because we could have written this like this. So we could have just had this all on one line, in which case we have to terminate that line and say that, okay, we're done declaring that particular thing. So the variable, the declaration or the implementation of P, where we're actually assigning it, we're setting up the instance. This is the format of actually setting those variables up front. Now, we declared an implementation of S1 up here, and we've declared a function. This function is called set. It is a member of S1. It has a self variable that is telling it that if you want to do anything with the variables that are part of the structure, refer to them via self, because that makes sure that instance is what you're looking at and not some other instance. And then you'll also notice that we've got two variables here. So self, and you're going to see here in a second that this function doesn't match the call. And the reason is because self is implied. It's automatically part of that function. And so down here, when we actually call p.set, so you notice set is part of P, it's part of that structure. So, but we call p.set, and you'll notice I don't have self here. I don't have anything here to even resemble self. I'm passing in the number 32 and a string of hello. So when we declared this, we declared it with I being 22, and we declared it with a string of hello world. But when we call set, we're actually changing that definition. We're telling it that I want to change the value of I and the value of S. And if you look up here, it says self.I equals J. J is the first variable that I passed in, not this. Self is there and part of the call, but it's automatic. But the first variable here is J, the second variable is K. If we come down here and look at this, the first variable is 32, and the second variable is hello. Now, I'm not real sure the purpose in having self be part of this, other than there is another important part of this. So when we call set, you'll notice that P is mutable, which I've told the system that I can modify P. So that means every field in P I can change. But when I make a call to this function, I'm passing these variables into that function to modify what I and P are, what I and S are, but I've not told the function itself that self is mutable. So in other words, I declared P is mutable, and I'm gonna be clear about this. I'm not real clear as to why it has to be this complicated, but this is the way that it works. So one would think that self would just automatically come in here and you wouldn't have to put it in the declaration. And you would also assume that because I declared P is mutable, that everywhere I call P, that I would be able to make changes. But that is not the case. Now let's show an example here. So the first thing I want to do is I'm going to jump out here. Let me save this. Let's jump out here and make sure that we are still compiling. Oh, well, we're not going to compile because of the point that I'm trying to make. So in order to do this, I would have to say, I'd have to tell it that self is actually mutable in this instance. So let's do this. I'm going to write this, and let's jump out here, make sure that we're compiling. And okay, so you see that the P is 32 and hello, so it did update the thing. But if we come down here, P is mutable, which means that I should be able to say P.I equals 44. Okay, so the fact that P is mutable here allows me to directly control what those variables are. But in this function, when we actually call the function, it's passing the instance variables in as self, and they are immutable by default. So just like everywhere else, the function call itself, even though P is mutable, the function call is passing an instance of that in, and it's not mutable. So I have to specifically tell it that it is mutable so that I can make changes to it. So again, it's just something that you kind of have to get used to. So you can see here that we are able to change the I variable directly, but if I want to change it inside of a function, I have to pass in that mutable for self so that it knows that I'm okay with making the changes to self. So the point here, and the book that they have on the Rust website, I actually bought it and I've been reading it on my Kindle, but you can actually read it on your computer for free on their website. It's an extremely well written book. I don't know who the guy is that wrote it, but it is probably one of the best programming books I've ever read. There are some things that you think he's skipping over, but he'll start covering them more, as you go through the book, like the double colons and, mutables and structures and all that stuff. Enums tie into these structures really well as well. So it's really worth reading the book to kind of get your head wrapped around exactly what all is going on. But the big thing I want to throw in here is that we have the ability to define structures. We have the ability to implement functions that are specifically related to those functions. And one of the things that I want to figure out next, and that's what I'm fixing to focus on, so I may do another video here in a minute. But one of the things I want to figure out next is the functions where you got multiple functions, where I was saying that you pipe the output from one to the other to the other. I want to understand exactly what is going on with that and how that works. So that's what I'm going to be working on next. And then we're going to get back into our application and start working on the REST side of setting up our app that we're trying to do.